Hi, this is question number 3 from the AQA Mechanics 3 June 2009 paper. In this question we're told that a fishing boat is travelling between two ports A and B on the shore of a lake. So there's A and there's B. The bearing of B from A is 130 degrees. The fishing boat leaves A and travels directly towards B with a speed of 2 meters per second. So it's leaving A and it's travelling directly towards B at a speed of 2 meters per second. So that's the direction that A is heading in. Okay, and we're told that there's a patrol boat on the lake that is travelling with a speed of 4 meters per second on a bearing of 40 degrees. So I'm just going to mark on a north line here. Let's put that in green. That's my north here, that's my north there, and we're being told that this one here, I'll mark it in blue, the patrol boat is travelling with a speed of 4 meters per second on a bearing of 40 degrees. So that's going to be 4 meters per second on a bearing of 40 degrees. So let's just mark in all the information that we know first of all. So that's going to be 2 meters per second for that one, black. And this one's going to be 4 meters per second, and we have an angle here of 40 degrees. Okay, and for part A we're being asked to find the velocity of the fishing boat relative to the patrol boat, giving our answer as a speed together with a bearing. So we want the velocity of the fishing boat relative to the patrol boat. And I'm just going to write down that I know that that's going to be the velocity of the fishing boat take away the velocity of the patrol boat. So I'm just going to write down the information that I know over here. So we want the speed and the bearing. So we're going to have a go at doing this geometrically. What I'm going to do is I'm going to take this information and I'm going to move it over here. So this represents the velocity of my fishing boat in red, and this here represents the velocity of my patrol boat in blue. Okay, and I also know that this angle here, this angle here is 130 degrees, so this angle here is 130 degrees, so if that's 40, this here is just going to be a right angle, because 1940 make 130 degrees. Okay, so using this formula here now, that's the velocity of the patrol boat, that's the velocity of the fishing boat, and I know that the positive of the fishing boat and the negative of the patrol boat is going to give me my fishing boat relative to the patrol boat. Okay, so I want the negative of this and the positive of this. So if I draw my arrow now, and I'll do a bright green one, and that's going to be going in this direction here. So the negative of the velocity of my patrol boat and the positive of the fishing boat, and that gives me that angle there. Okay, and then from there I can draw another north, and we know that this angle here, if that's 40, this here is going to be 140 degrees. Okay, so that there's 140 degrees. Right, so using, well, I've got a right angle triangle here, so I should now be able to work out this angle here, and if I take that away, if I take this angle and this angle away from 360, that should tell me my bearing, which is going to be from the north in that direction there. So that's the bearing that we're looking for. And also using Pythagoras, because this is a right angle triangle, I should be able to work that out there. So I'll do that now using Pythagoras. That's going to be 4 squared plus 2 squared square rooted, so that's going to be root 16 plus 4, which is root 20. So that's going to be root 20 meters per second, and this here, well, we can work out this angle, which I'm going to call theta, and I know that tan theta is going to be equal to 2 divided by 4, opposite divided by adjacent, and theta is therefore going to be equal to I'm going to do the inverse tan a half, and that gives me 26.6 degrees. That's going to be 26.6 degrees. Okay, so if I do 140 plus 26.6 and I take that away from 360, that's going to tell me my bearing. So I've got 360, take away 140 plus 26.6 degrees. So I want to do plus 140 . That tells me I've got a bearing of 193 degrees. So my bearing 193 degrees, and the speed is going to be equal to root 20, which I'm going to write as 4.47 meters per second to 3 significant figures. Meters per second. Okay, right, so I now know my bearing and my speed for this, so that's part A completed. Now part B says when the patrol boat is 1,500 meters due west of the fishing boat, it changes direction in order to intercept the fishing boat in the shortest possible time. Okay, so I'm just going to create some room for myself over here. Okay, so in order for the the patrol boat to intercept the fishing boat, it needs to appear to go in this direction here to the fishing boat. So what we're saying is that there is going to be the velocity of the fishing boat, the velocity of the patrol boat relative to the fishing boat. So to the fishing boat is going to appear that the patrol boat is coming towards it in this direction here from the west. Now we can also write down that we know that the velocity of the patrol boat relative to the fishing boat is going to be equal to the velocity of the patrol boat take away the velocity of the fishing boat. Now because the velocity of the patrol boat is what we don't know, I'm going to make that the subject, so I'm going to say, well, the velocity of the patrol boat is going to be equal to this relative velocity plus the velocity of the fishing boat. Okay, so from this diagram here now, I can take my velocity of my fishing boat, which remains unchanged, remember that's still going to be going in the same direction, and I'm going to move that over here. Okay, so just stick that over there for the time being. Okay, make that a little bit bigger. Move that over there. Right, okay, so from this we know that this plus this is going to give us the velocity of my patrol boat. So I'm going to draw the velocity of my patrol boat in here. And that has to be going in that direction there. That's going to be the velocity of my patrol boat, and that's still going to be going at 4 meters per second. So that's still going to be equal to 4 meters per second. Okay, so it's only changed direction, it's not changed its speed. Now, I know that this angle here is 130 degrees. This here is 90 degrees. So this angle here is going to be 130 and 90 is 220. They have to sum to 360, so that's going to be 140 degrees. Okay, I'll just mark that then. That's 130. Okay, right, so we should now have enough information here, because I've got an angle on the side that matches, and this is the angle that I want to find out here, which I'm going to label as alpha. I do know that I should mark this on really. I do know that this here is going to be my north, that's west, so that's going to be 90 degrees there. So my bearing is going to be given by 90 plus alpha, and that's going to tell me my bearing in which the patrol boat should travel. Okay, so we've got sine alpha over 2 is going to be equal to, so sine alpha over 2 is going to be equal to sine 140 divided by 4. So sine alpha is going to be 2 sine 140 divided by 4. So we've got 2 sine 140 divided by 4, and that tells me that alpha is going to be equal to 18.7 degrees. So alpha is equal to 18.7 degrees. Okay, so my bearing is going to be equal to 90 plus 18.7 degrees, and to 3 significant figures, that's going to be 109 degrees. So my bearing is actually going to be 109 degrees. Right, so that's part I done. Okay, so the second part of this says, given that the patrol boat intercepts the fishing boat before it reaches B, find the time in seconds that it takes the patrol boat to intercept the fishing boat after changing direction. Okay, so we know that it changes direction when it's 1,500 meters due west of the fishing boat. So we need to know the actual speed of the patrol boat relative to the fishing boat. So we need to know what speed this is travelling. Right, so again we can use this information here, because if we call that speed over here, let's just call it x. Okay, so x is our unknown, that's the speed over here. Then I know that that angle there is going to be, we can do 140 plus 18.7 and take that away from 180. So 140 plus the 18.7, take that away from 180. and that tells me this angle here is 21.3 degrees. That's 21.3 degrees. Okay, so and I want to work out x over here, so I'm going to say, using sine rule again, I've got x divided by the sine of 21.3, and that's going to be equal to, and we can just use this here, so we've got 4 divided by the sine of 140. Okay, so using my calculator I can now work out what x is, so I've got the sine of that, and I'm going to times that by 4, and I'm going to divide that by the sine of 140. And that tells me that x, or the speed here, is going to be equal to, that's what it was, 2.26 meters per second. Okay, so that's how fast it's travelling here, 2.26 meters per second. It needs to travel 1,500 meters, so we want to know how many seconds that's going to take. So to work that out, my time is going to be 1,500 divided by 2.26 seconds, and that's going to tell me 1,500 divided by the 2.26 seconds, and that tells me it's going to be, to 3 significant figures, 665 seconds. 665 seconds. Okay, and so that's part 2. That's going to tell us how long it takes to intercept. And then part 3 says, state a modelling assumption necessary for answering the question other than boats being particles. Okay, so I could say that, well, the assumptions we're making is that there's no wind, for example. That could be one thing. Or it could be that we're taking into account that when it changes its velocity over here, it changes its direction, that's instantaneous. It doesn't have to steer to change or anything, it just instantly changes. So anything along those lines. I'm just going to say that I'm taking into account that there's no wind. Nice and simple. So no wind is an assumption that I'm making. Okay, I hope that was useful, and I hope this makes sense to you. Thanks very much for joining me, and I'll see you next time.